not recording the answer. Okay, so last time we already done for source, common source, and common drain. And the last one, that will be a common gate, okay? And this is a common gate. Uh, Input will be applied to the source, and the output will be coming from the drain. And this is basically AC configuration. And if you want the input impedance, then you can see you get a RF in parallel with 1 over GM. Okay? And also the output impedance here, looking into the amplifier, you can see you get a big RD. Okay? So that EL equals big RD. Okay? We don't care about small rd. And the gain will be equal to GM times RD. However, make sure you must be understand if you get the load in here, then that load must be parallel with the RD. Okay, common gate amplifier has no phase shift between the input and the output. Okay, and now they've given you the example here. For this circuit show, VGSQ equal minus 2.2 volt and IDQ 2.03 milliamp. And they want to your guy to solve it for the following. Now, this is basically common gate, so that's why gate will be routed. Okay? And now go ahead and do your calculation for me quick. Okay, who get the GM0?
I got 5.
Perfect. Okay. Yeah.
Hey, Mr. Pham, can I ask a question?
Go ahead.
On the right side, you got V pinch off is equal to -4. So that means VGS off is 4. And I realize in the formula for figuring out GMO that it's the absolute value, but I'm just for knowledge wise, I'm asking, in this case, is VGS off, is it +4?
-4.
Oh, -4. So, okay, yeah, that's what I wanted. Yeah, right there. Okay, got it.
They did a form, from document from some university.
Yeah. No
I
problem.
don't understand how come they can using that equal negative.
Yeah.
Suppose they say positive, that'd be fine.
And Mr. Fairman, also the pinch-off voltage, it's mainly positive, huh?
Yeah,
Because
VP.
usually the VGS off is negative and the pinch-off is positive.
Exactly.
Okay.
Who get EM? The thing that we need the answer here for the other student, they cannot follow it. Okay, when they get it, they have to do it over again. They know which correct answer.
Okay. Hold on, Mr. Pham, we're working on it. It's in the oven.
Some of you guys doing very good, so that's why you need to do the calculation. We can help the other student.
4, and then
I'm not sure, but I got 2.25. I don't know.
VGS.
Very good.
Okay, good. 2.25.
Right.
So that's the same as
Then GE.
2 divide 4. Plus 4. Oh, negative. That's negative. 3.2 -5, 4, 18. What over GM? Reciprocal. Okay. Reciprocal plus 1.1 EE. Did anybody get 316.5 for the ZN?
I got 3.18.
Because what I did is I put one, we figured out GM to equal 2.25 millisiemens. So if you, so I put that in parallel with RS, and then that should be approximately ZN. The formula on top.
You have to tell me what the unit. I want kilo ohm.
Okay, hold on. Okay, then that'd be like 0.315 or something like that. Let me do it again. Okay, 2.25.
I think the answer is 0.316, you know?
Yeah, 0.31.
Yes, I got 0.312. Yeah. Z out is 3.6 kilo ohm.
Exactly.
Yep, that's what I got all those.
8.1 AV.
Perfect.
I got 324 millivolt
Yes.
for via out.
Okay, you done it?
Mr. Pham, I
Hello?
missed it. Mr. Pham, I missed it. Where's the VN at?
40 millivolt.
You didn't see the display up there?
Must have missed it. I don't see it. Where's that?
How? Right here.
Oh, okay. I'm sorry. Yeah, there we go. 40 millivolts. 40 millivolts. Yep. Yep. That's right.
Okay. Now, I ask you a question. If I want you to measure the voltage here, which test equipment you using?
Can you repeat the question?
I said if I want you to measure the voltage here, okay, which test equipment you should be using?
Oscilloscope.
Oh,
The scope.
Yeah, oscilloscope.
Not the right answer.
Multimeter?
Multivoltmeter.
When they said V in equal 40 millivolt, what that voltage?
Is that RMS?
Yes.
Okay, then if that's RMS, you can use the meter and then use your calculations to go like peak to peak or whatever.
That's what I asking you. If I want to measure voltage here, the answer will be DMM.
The black lead go to ground and the red lead go right there where your red dot is at.
You must be using DMM, not oscilloscope. Oscilloscope will be measured at peak to peak voltage, not the IMF.
Hey, that's another thing too. In electronics, is it typical? Okay, for instance, like right there, you got 40, and then obviously little m big B, which is millivolt. And then sometimes you'll have on there millivolts RMS, or sometimes you'll have 40 VAC, which VAC and RMS is the same thing. Is that correct?
Correct. If they not put anything, that means VIMF or VAC.
Okay.
The thing I suppose the oscilloscope is not display VIMF. Except, we're using the oscilloscope in the lab, they will be given you VIMF. But normally they not. Okay?
Okay.
So I don't go through that one for now. Let's see. Come on, get here.
Your keyboard is covering it, Mr. Pham.
That's what I try to put it down. Okay. Okay, I'm not trying to do this problem. They will be almost the same like the other one. Only thing is now they adding
The load.
the load. That's only the difference.
So little RL will be in parallel with RD.
Exactly. That's what I want. Maybe on your final test. Okay, now we need to go to the other one.
The comparator.
Exactly. That's what we want to go to that one. The thing is, this is not a major chapter, just a very minor. Okay? And if you, we need to emphasize will be what diode, transistor, JFET, op-amp. Okay? That is a major problem. This is a very simple thing. Okay. Comparator is a type of the op-amp circuit that try to compare two inputs voltage and produce the output in either two state indicating the greater than or the less than relationship of the input. That means you can get the comparator that look like this one here. Okay, and you get a positive, you get a negative V out here. And you can get a positive input and you get a negative input. Okay, and that will be the blood using a blood saturation. And that will be a minus V saturation. Normally, V saturation will be a less than the power supply. Okay, for the op-amp around 1.4 volt. That's okay. Now, comparator and they just compare, okay, the positive input here to the negative input here to see which input will be higher. Okay, so basically V at the positive higher than V at the negative. Then that will be given you V out equal blood V saturation. And if V at the negative greater than V at the positive, then V out minus V saturation.
Mr.
That's
Kern,
very simple.
can you zoom out a little bit, please?
Which one?
Yeah, just zoom out a little bit so we can see the rest of your page.
Oh, let's see. This one okay?
Yes, thank you.
Okay. In here, we already telling you. If input positive higher than negative, V out equal blood V saturate. And if V input positive less than input negative, output will be equal negative saturation. If you're using 15 volt saturation, output they can be go to 15 or minus 15, depending on which input will be higher. So when you're looking into any circuitry, they're using the op-amp. This is the op-amp here. Then we need to recognize, is it the amplifier, okay, or the comparator? How do we know that comparator?
There is no feedback.
How do we know is it this circuitry is a comparator?
Two input voltages.
It's not an amplifier.
You got two inputs, an output, and two deal, one for VSAT and one for V minus VSAT.
No, that's not quite a good answer. When you're looking into the op-amp circuitry, you need to identify, this is a comparator, or this will be a inverting amplifier, non-inverting, whatever, differential amplifier. How do we recognize comparator?
That's a good question.
Normally, you can recognize by see they have a no feedback resistor in this case,
Oh, yeah,
right?
right.
I said this.
No feedback for this example here. Later on, you can see they can get a feedback, but a little minor different. We'll recognize that later. Easy to recognize they have a no feedback. Okay? And now this circuitry they call a zero level detection. That means they try to compare the signal with the route, right? This is a zero.
Right.
This is a signal they want. So that's why they given you the sine wave right here. Okay?
Mhm.
So when the V in positive compared to the route, so the positive input will be higher than negative, right? So output will be go to V saturation. So that's why you can see right here, V output, they go to the V saturation. We call V out maximum, okay? Then when they get the negative cycle, okay, so a negative on this side compared to real zero, so will be less than zero. So input negative will be higher than positive. Output will be go to the negative saturation. That will explain how this circuitry, this drawing here, how that coming.
So is that the same as that little formulas that you drew up top or something?
That normally it's the same thing exactly on the bottom here. However, they compare in this case they compare to 0 volt. That's why they call a zero level detection compared to route. Okay?
Wait a minute, wait a minute. Thank you, Mr. Vam.
Okay. That one here. Okay, we already uh, get the non-zero level. Okay. Now on this circuitry here, what they compare with,
What you compare what's on the plus to what's ever on the minus side.
so in this comparator, they compare input here with what?
With the V reference.
Exactly. Whatever we reference here.
Mm-hmm.
Okay. Now on that one,
They're
so
comparing the VN to that R whatever R1 R2 is.
exactly. This is they compare with the reference voltage by a voltage divider.
Divider.
Yeah,
Voltage divider.
right.
Okay. Now you can see on first one here, they input will be sideways here, and your V reference will be here. Okay. So they compare to V reference. So if you're looking here from 0 to this point here, so basically they less than V reference, right? You right here. that less than V reference. So if they less than V reference, that means V reference at the negative here higher than the positive. The output will be go to the negative saturation. You see that right here, negative. Okay, and from this point here to this point here, they higher than reference. So that's why the output will be at the maximum saturation, positive. Okay, then also from this point to this point here, input will be less than the reference. Then the output will be go negative saturation. That's how it works.
Hey, Mr. Pham, does this one apply to, does this one have to do with the voltage divider one you just did?
Now, this one. V reference.
Oh, okay, it has to do with that one.
The thing that we don't have enough room.
Okay,
So both at the same time. So that's
Okay.
why.
all right, thank you.
Mr. Pham,
Yes.
could you please explain again the idea of non-zero level detection?
You mean go back to here?
He said 9-0.
Yeah, no, non-zero detection, non-zero level detection.
Non-zero, that means they not compared to round.
Okay, okay.
They
Thank
compare
you.
to something else.
Got it. Thank you.
Okay, like one they compare to the V reference. And the other one they compare to voltage divider. Okay, so now that one, they compare. I don't have any example for the voltage divider. That easy.
No, but I understand. I understand the non-zero level
Okay.
detection. Thank
Now, on that one, if I given to you 30 volt, and also I given to you VG 5 volt. So what they compare with,
With 5 volts.
perfect.
Is it comparing with the Zener diode, right?
Right, the thing is, breakdown.
Right, because 30 is way higher than 5.
Right, so that's why here, they compare with the 5 volt. Exactly the same, they compare with the V reference, okay? If you understand how the comparator working, so that's very, very easy, okay? They just compare input positive and a negative. Which one is higher? V at positive higher than V at negative. Output go to the maximum plus V saturation. And if the negative input higher than positive, they go to the VL go to negative saturation.
Hey, Mr. Pham, go back to that just a second. On this one here, you have where VN is at. We don't know what VN is at, so we don't really know what the plus side is, correct?
Right.
So I guess I'm a little bit confused, only because all that writing that you did, the 30 volts, the 5 volts, whatever, that's on the minus side. But what's on the plus side?
Oh, normally when they set blood 30 volt, right?
Right.
Okay. So normally the power will be this way. the other side must be negative. If they not say negative, that means you have to understand the power supply. The other side must be grounded.
Okay.
They not here, okay? They not at this point. If we make it clear, I can draw this way. It's supposed to be that.
Okay.
Normally, when before I given a lecture for you, you're supposed to be download and go over, couple
Yep.
times. So
But sometimes you can't see it, Mr. Pham, the way it's drawn. I mean, it's a little bit more clear now.
okay, but normally that's what normally they when they ask you, they given the way. I give it to you here.
Okay.
Okay, that means they don't get to draw everything. They just draw exactly that one.
Mm-hmm.
Okay, now I get a question here. Okay, I gave it to you. VG 10 volt. Okay, plus V. Let's see. No, forget it. The thing is, we have to give you a little more information. We don't need that for now. Let's see, what else? Here. The input signal as so applied to comparator circuit. Draw the output showing its proper relationship to the input signal. Assume maximum output will be 12 volt and minimum will be minus 12 volt. So first thing, they compare to the V reference. Then you need to know what the V reference equal right here.
Voltage divider, right?
Perfect.
Yeah, 1.63. 1.63.
Okay, 15 volt times 1K, right?
Yes.
Divide 1 plus 8.2. So you get 1.6 or what?
1.63.
Okay, 1.6. Okay. So basically, you can get a 1.6 right here, for example. Okay. So now, this is less than reference. Okay. That means positive less than 1.6. So what the output equal?
Minus saturate.
Perfect. Minus saturation. You can go down here. Okay. minus here. Then this is higher, right? So that you
Yeah.
will go to positive. This one look like. And this here, they're supposed to go right here. Okay? Less than. And they will be minus. Okay.
Saturated.
Same thing on the other one. Okay, so I will stop here. Okay, you guys ready to take the test?
Okay, saturation is not minus 5 volt, yeah? It's something else. V.
This one, okay,
Okay.
they draw 5 volt that they given to the max.
Oh, okay.
And minus 5, that means they telling you the minimum. They
Oh.
don't care about saturation.
Mhm.
Okay?
Yeah.
I want to stop this guy. Okay, now. Quiz number 19, right? Okay, let's see.
Yes.
19. Okay, equi1819. Just a minute. Okay, we need to share.
Looks like it's been 3 minutes now.
And the thing is, some student try to get in.
Okay.
If you don't touch the mouse, it should be okay.
Denise.
Okay, good night.
Mr. Pham,
Yes, sir.
on question 12, it only show answer A, B, C, and not D.
Yeah, D should be at -3 dB points.
Minus 3 dB point.
Yes.
Okay, thank you.
You're welcome.
Right here, right?
Yes, number 3. Yes, exactly. D right there. D is at -3 dB points. Okay, looks good.
Okay, any question?
Everyone's good.
Okay, otherwise, good night, everyone.
Good
Okay,
night.
good
Thank
night.
you.
Bye-bye.
Thank you.
You're welcome.